Assalamualaikum and hi, my name is Wan Nurlana Izli Milad Raza and my matrix number is 2021687588. So I will talk about Newton's first law, which is inertia. What is Newton's first law? Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its states by the action of an external forces. So now let us see some example for this concept. There is two examples that I will show to you guys, which is inertia of rest and inertia of motion. First, let us see the example for inertia of rest. From the video, what is the concept of inertia that can be related here? Okay, given a piece of paper with a coin on top of the glass, then the paper is pulled quickly while the coin falls into the glass. The paper moves away due to the force of the finger, but the coin remains in its position due to rest of inertia and then falls into the glass. Here we have shown the concept of inertia because the object, which is the coin, stay in its original place and still stay there until we or something else move it. The property of a body to oppose any change in its states of rest is known as inertia of rest. Okay, now let's move on to the next example, which is inertia of motion. Look at the ball from the video. From the video shown next to me, the ball is originally at rest and will remain at rest unless moved by an unbalanced force. In the video, there is a force exerted on the ball when it is kicked. So the ball is in motion and will continue with a constant speed and direction unless an unbalanced force acts on it again.
I will explain more about Newton's second law. Newton's second law, also known as the law of force and acceleration. A force upon an object causes it to accelerate. According to the formula, net force is equal to mass multiplied with acceleration. So the acceleration of the object is directly proportional to the force and inversely proportional to the mass. The second law of motion states that F is equal to M multiplied with A can be used to calculate force. In order to calculate the force, the mass of the item is multiplied by the rate of change in velocity. A equal to F over M is a formula that can be used to calculate acceleration. How does Newton's second law apply to a car crash? According to the definition of second Newton of motion, force is the dot product of mass and acceleration. The force in the car crash depends either on the mass or the acceleration of the car. As the acceleration or mass in the car increases, the force which with the car crash takes place will also increases. Next, I will explain more about objects thrown from a height. When an object is thrown from a certain height, the gravitational pull of the earth helps it to develop acceleration. The acceleration increases as the object advances towards the earth. According to Newton's second law of motion, the acceleration developed by a body is directly proportional to the force. When the object hits the ground, the impact force comes into action.
Hi. Okay, now I will explain about Newton's third law. Okay, actually, what is Newton's third law? Newton's third law states that for every action force, there is reaction force of equal magnitude and acting in opposite direction. So, we can conclude that in this law, there are two forces with the same magnitude but have a different direction. This law also can apply to objects that are in two states, which is object in motion or object at rest. Okay, now let's rewatch one video that presents to us Newton's third law in real life. So, let's check it out. Wow, the train was moving fast, right? But do you know that the movement of the train has applied Newton's third law? Okay, firstly, what is the action and reaction from this example? The action from this video is the tires of the train push on the track, and the reaction provided is opposite from the action, which is the track push on the tires, which means that when the train is in motion, the tires push the track back. In response to that action, the track push the train's tires forward with the same magnitude of force but in the opposite direction. For more specific, train can slide forward because of the backward movement force produced by the train tires. This backward movement is called as action. As a result of this action, the track provides an equally large movement force in the opposite direction of the action, which is the forward direction. The force produced by the forward track is called as a reaction. So we can conclude that the train can move as usually with the existence of Newton's third law concept in our life. Many people do not know that Newton's third law also applies to object at rest. I will give you guys a simple example, which is one book on the table. Who's know that with a simple thing also can apply to Newton's third law? Okay, now I will explain about this example. You guys can imagine, just imagine that one book considered as rest on the table. The Earth's gravity pull down upon the book, which is we call as action. And the reaction to that action is not the support force of the table holding up the book, but the gravity pull on the book acting on the earth. That means gravity of the earth from above and below the books has a force of equal magnitude but the opposite direction. It shows to us the example of Newton's third law because it's contain two forces with the same magnitude and different direction. We can see that Newton's third law is very important in our life because we do it every day. So after we learn about Newton's third law or another Newton laws, we know that it's very important in our daily life. So we have to do it. What we have to do is open our eyes and see our surrounding and apply what we learn.